everyone. Welcome to the application of quadratics lesson. We are nearing the end of the quadratics unit, so just hold tight. You are almost done. Please email me with questions. Make sure you're using your school email address because if you do not use your school email address to complete the IP, then it won't submit. So make sure you're using that school email address while you're logged in so that when you click on the IP, it'll submit for you when you get to the end. Remember that Thursday is the last day of the regular school year before remediation week begins. So get in those missing assignments. If you don't know what those are, just email me and I'll send them to you. Make sure you have your pencil and paper out today. There are a couple of practice problems that I want you to try out. Quarter 4 ends on Thursday, which is May 21st. If you're passing with a C or better by then you're absolutely done. If you are not, then you will need to continue working for 2 more weeks. So make sure you get those assignments handed in. The bonus project is not due until May 22nd at midnight, and it's worth 20 points. If you want more information about that, please go to the Haiku page and look at the Algebra 1 Semester 2 e-learning project link and read what you need to do to complete that project. I've gotten a project from Stacy K, LJ, Hanaya, as well as Chris, so awesome job to you all. I hope I receive more. Celebration, mostly I am just really overwhelmed with how well you all are doing with this e-learning. This is something that I've never done myself, so I know that it can't possibly be easy. Like, doing high school online is probably nothing that you ever expected to do, but since you rose to the occasion and you got those assignments in and you're asking all the questions, it just shows that nothing can stop you from being great. So my celebration this week, I'm just gonna draw a heart that's green, I think, just to show that I see all that you are doing and I wish you all the best. Okay, so let's review what we've done so far. So far, when we're working with quadratics, we have always been given a quadratic or a quadratic equation to solve and or graph. Okay, today we are going to write our own quadratic equations based on word problems, and then we'll solve them. So by the end of our lesson, you will be able to write and solve a quadratic equation based on a word problem. So let's go. I already know word problems are not always what you want to do with your time in your life, but today I need you to set aside some time to just open your mind to word problems, and I'm going to show you how to do them, and it'll be great, and then you'll be done, and then that's all. Okay, so hang in there. So are you ready to continue with this lesson? So at this point, we are nearing the end of our lessons on quadratics. So if you have trouble solving, graphing, or identifying features of a quadratic, please stop this video and go review lessons from May 6th all the way to May 14th. All of those things like solving, graphing, and the features of a quadratic are within those lessons. Okay, so here's our first example problem. We are going to write and solve a quadratic based on this word problem. So, example 1. The length of a rectangle is 6 inches more than its width. The area of the rectangle is 91 square inches. Let's find the dimensions of the rectangle. The first thing we want to do is go through and underline the important pieces of our word problem. So we have length. Length we're going to indicate as L. We have this word is, which means an equal sign in math. Then we have 6 inches, which is just 6. And then more than is addition. And then we have width, which will indicate with a W, okay? And then it says that the area, will indicate that with an A, of the rectangle is equal to 91 square inches. So our goal today is to find the dimensions of the rectangle. Okay, so this word dimensions, that means that we're trying to find the length, which is indicated by L, and we're also trying to find the width, which is indicated by W. Okay, so let's find that length and width of this rectangle. So the first thing we want to do is draw a picture. So we'll just draw a picture of a rectangle. And let's label the length and the width. So the width is just indicated with a W. So we'll just, our equation for width is that width is equal to W. Our equation for length, however, is going to be that W plus 6. We always try and write that variable first and then our constant. So I know I wrote it as L equals 6 plus W at the top, but I went ahead and switched those just so that our variable was first. Okay, so we have part A done. We labeled our rectangle with width and length. Okay, so let's solve our quadratic equation. But before we can solve it, we'll need to write one. So it asks us, or it tells us, that our area is equal to 91. Okay, well, we know also that the equation for area is length times width. So we know that our length times our width is equal to 91. Okay, so let's go ahead and fill in the information that we have for length. Well, we know that our length is equal to W plus 6, and we get that from our word problem, and also labeled that in our diagram or our picture. And W, there's nothing to substitute W with. W is representing width, and that's all that we have about the width. So we're just going to keep that as W. And that's equal to 91. Okay, so now we want to use the distributive property to simplify W plus X times W. And also we're going to have to subtract 91 from both sides because we need to get it in standard form. So when we do all the simplification, we'll get W squared plus 6W minus 91 is equal to 0. We have now written our quadratic. So when I ask you to write the quadratic, I want you to multiply your length times your width all the way until you get an equation. Okay, so on your homework, when you see write, I want you to end up with your final quadratic as your answer. Okay, now we can solve it. So we're going to go over here to the right, and we're going to use the quadratic formula to solve this. Okay, so we'll have x equals negative b. We'll fill this in a moment. I'm just going to outline it first. Plus or minus the square root of b squared minus 4ac all over 2a. All right, let's fill this in. So we have b, our b value is 6. B squared minus 4 times a is 1, times c is negative 91, over 2 times a, which is 1. Okay, let's simplify. So we'll have negative 6 plus or minus the square root of 36 plus 364 all over 2. And this is negative 6 plus or minus the square root of 36 plus 364 is 400 all over 2. Okay, remember that this plus or minus tells us that we need two equations. So our first one will be negative 6 plus 20. 20 came from the square root of 400 is 20. Okay, all over 2, and that will give us 7. And then we have negative 6 minus 20 over 2, and this gives us negative 13. Okay, so we're looking for length and width, so we have to decide which of these answers, either 7 or negative 13, can be used to find our dimensions. Well, we can never have a negative length value, or we can never have a negative width value. Therefore, we cannot use our negative 13. Okay, the value that we have to use to find our dimensions is going to be the positive number, which is 7 in this case. So now we can actually find our dimensions, and we're going to do that by plugging in 7 into the equations we found at the beginning. So our equation for length was equal to W plus 6. Now we're going to plug in that 7 for W and simplify. So our 7 goes here because that's what our W is equal to. And when we add 7 plus 6, we get 13. Okay, so our length is 13, and we can say inches because that is the unit. Okay, and our width is going to be that value of just 7. Okay, so our width is 7 inches and our length is 13 inches, and we have successfully found the dimensions of this rectangle. Let's try another example. So one side of a rectangle is 4 inches shorter than 3 times the other side. Find the side lengths if the area of the rectangle is 310 inches squared. Let's go ahead and add that in for this. Perfect. All right, let's draw a picture. Well, let's rewind. Before we draw a picture, let's go ahead and label our word problem. So it says one side. One side is going to be indicated as L is equals 4 inches shorter than, subtraction, 3 times the other side. So the other side we're going to indicate with a W. Okay, so 3 times the other side is 3 times W. We want to find the side lengths if the area is that A is 310 inches squared. Okay, so we have everything in our formula, everything in our word problem annotated. Let's go through and solve it. Before we can solve, we have to write our quadratic equation, don't forget. So let's write it first. So to write it, we take our area is equal to length times width, which is equal to 310 in this case. Our length equation, 4 inches shorter than 3 times the width. Now, in our word problem, it looks like we have to write 4 minus 3W. But it says that it's 4 inches shorter than 3 times the other side. So how we actually write this is like this, 3W minus 4. Okay, so you have to switch the order. That is very, very important. If you switch the order on your IP, I know that you watched this video. And then our width is just W still, equals to 310. Now we can use the distributive property and subtract 310 from both sides. And now we'll have our final quadratic. Our final quadratic will be 3W squared. Uh-oh. Let me erase that real quick. Come on. Okay, so we'll have, if I can fix this. Okay, so 3W squared minus 4W minus 310 equals 0. So this is our written quadratic. Okay, now let's go ahead and solve. Usually when I have large numbers like 310, I automatically just go ahead and use the quadratic formula. It'll make your life easier, I promise. So let's outline our quadratic real quick, and then I'll fill it in a second. Okay, so negative b is negative 4 this time. Okay, negative b squared minus 4 times a is 3, times c is negative 310, all over 2 times 3. And this simplifies to 4 plus or minus the square root of 16 plus 3,828 all over 3. And this is equal to 4 plus or minus the square root of 3,844 all over 2 times, looks like I messed up. This should be 2 times 3, which is 6. Okay. Uh-oh. And I also need to fix this to be a 6. Okay. My bad. All right, remember the plus or minus symbol tells us that we need to make 2 equations. So we'll have 4 plus the square root of 3,844 is 62. All over 6. That'll give us 11. And then 4 minus 62 over 6 is equal to negative 9.7. So we have to decide which of these two x or w values with values that we can use. Okay, remember that we can only use the positive number. So we can't use negative 9.7 because it's negative. We have to use our positive value, which in this case is 11, to find our length and width of this rectangle. So we're going to have our length equation was 3w minus 4. So we get to substitute 11 in for that w this time. So we'll have 33, which is 3 times 11, minus 4. 33 minus 4 is equal to 29. And inches is our unit. So we found the length. And then the width is just going to be 11 inches. Okay, so we found the length and width of this rectangle. Well done. All right, this is a problem where you can try, okay? I want you to try parts A and B and C, and then click play to check your answer. Go ahead. Okay, so our diagram is going to look like what they've been, which is a rectangle. Okay, we have to annotate our word problem so that we know what to write our equations as. So we have length is 2 feet less than twice the width, so that's 2w. The area of the garden was, we can also put equals there, 400 feet squared. Okay, so remember, whenever we have that subtraction or that less than, we have to rearrange our equation. So this is actually 2, I wrote a 3, strange. 2w minus 2. That's actually how we write it. And our width is always just w. So when we write our quadratic, length times width is equal to that total area, which is from the word problem, which tells us 400. Now we can substitute length with the equation that we wrote in our diagram. Okay, and that equation is 2w minus 2. We want to distribute w to everything in parentheses and subtract 400 from both sides. And this will give us our written quadratic. So our quadratic is 2w squared minus 2w minus 400 equals 0. So we have successfully written our quadratic. Let's solve it. So let's outline our quadratic first, like I always like to do. And I've been labeling this x. I mean, we can technically label it w to keep consistent. Okay. B squared minus 4ac all over 2a. Let's fill that on in. So our b this time is -2. So -2 squared minus 4 times a, which is 2, times c, which is -400, all over 2 times a, which is 2 times 2. This is equal to 2 plus or minus the square root of 4 plus 3,360 all over 4, which is equal to 2 plus or minus the square root of 3,364 all over 4. Okay, that plus or minus sign tells me I need two equations. The first one is w equals 2 plus, now the square root of 3,364 is equal to, I didn't write this down. Let me calculate it really quickly. 3,364 is 58. So we'll have 2 plus 58 over 4, and that is equal to 15. And then we'll have 2 minus 58 all over 4, which is -14. Okay, so the only value that you can use here is going to be 15. 14, -14, you can't use because it's negative. Okay, so let's plug that in. So L equals 2w minus 2, which we can replace w with 15. And when we do that, we'll get 2 times 15, which is 30. 30 minus 2 is 28, and we have feet this time. Okay, so our length is 28 feet. And our width is always what we plugged in to find length. So our width, let's change to black here. Width is 15 feet. Great job. Okay, so some key phrases that we want to look for when we are solving quadratic word problems is maximum height and reaches the ground. Maximum height means that the vertex is what we're going to have to find to answer the question. If we see reaches the ground, that means that we have to plug in 0 for h. And then we solve by factoring or quadratic formula. Okay. So keep an eye out for these key phrases in the next slides. Okay, here's a physics application. We throw an object upward from the top of a 1,200 foot tall building. The height of the object measured in feet, t seconds after we throw it, is h equals -16 t squared plus 16t plus 1,200. Okay, first let's draw a picture. Well, this is a tall building that's 1,200 feet, so I'm just gonna try to draw that. And I throw something off of it. There we go. There's our picture. Where is the object 3 seconds after we throw it? Okay, so where is the object 3 seconds after we throw it? Well, we have nothing but variables of t and h. Negative 16t squared plus 16t plus 1200. That is the quadratic that we're looking at. So whenever it asks me where is the object and it gives me the number, I just need to plug that in for t. And then we simply simplify and figure out what that height is, h. So I'll have negative 16 times 9 plus 48 plus 1200. This is all adds up to 1104 feet. So the picture now would probably look like this. So 3 seconds after we throw it, 1104 is probably around here somewhere. So the ball or the object is about right here, 3 seconds later. Okay, let's do C. When will the object reach its maximum height? How high will it be? Maximum height tells me that I need to find my vertex. Well, the first step, it says when. That means I need a time. So to find the time, I have to use negative b over 2a. Remember this equation? It's our axis of symmetry equation. Okay, so I plug in my b value and my a value from that quadratic over here. So b is 16, a is negative 16. Okay, so this simplifies to negative 16 over negative 32, which is simply 1/2. Okay, so this answers the question, when will the object reach maximum height? It will reach maximum height after 1/2 seconds. Okay. Now, how high will it be? We have to go ahead and plug in 1/2 into our original quadratic. So it'll be h equals negative 16 times 1/2 squared. I'll fill this in a second. Plus 16 times 1/2 plus 1200. Okay. So let's go ahead and fill 1/2 because I have to plug that in to figure out how high it will be. Okay. So negative 16 times 1/2 squared. Well, we do 1/2 times 1/2, we'll get 1/4. Okay, so it'll be negative 16 times 1/4 plus 16 times 1/2. Half of 16 is 8 plus 1200. Negative 16 times 1/4. We do negative 16 times 1 divided by 4 is negative 4 plus 8 plus 1200. And this all comes out to be 1204 feet. Okay, so the maximum height that this object will ever be is 1204 feet. So let's draw a picture, tiny picture. So this wall is 1200 feet tall. The object, when thrown, goes about like this and then it goes down. So our maximum height is about 1/2 a second after I throw it. And it'll be about right here. So right there is about 1204 feet. Okay? All right. Last question about this same word problem. When will the object reach the ground? Okay, our keyword, our key phrase here is reach the ground. Remember, that means that we have to plug in 0 for h. So we'll have negative 16 t squared. Those boxes with the question marks, those are supposed to be the t squared and the t, but it didn't print out right, so I'm just rewriting it. So 16t plus 1200 equals 0. Okay, we plug in 0 for h, and now we have to just solve this using a quadratic formula or factoring. Since we have a lot of large numbers, we'll just go ahead and use the quadratic formula. So we'll have x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, I'm about to tell you the code word. The code word is code word. Ready? It is 4. Why do I say 4? It's 4 because you have 4 more days of e-learning. If you have a 60% or higher, that is, you have 4 more days of e-learning before you are all done. So that code word for today is 4. Okay, back to our quadratic equation here. Let's plug in our a, b, and c. So b is 16. We need b's here. A is negative 16. C is 1200. And a is negative 16. Okay, so this simplifies to, I love to get black back. Simplifies to negative 16 plus or minus the square root of 256 plus 76,800 all over negative 32, which is negative 16 plus or minus the square root of 77,056 over negative 32. Okay. Now the square root of 77,056 is 277.6. So this plus or minus tells me that I need to set up 2 equations. So negative 16 plus 277.6 divided by negative 32. And that equals negative 8.29. And then we have negative 16 minus 277.6 all over negative 32. And this gives me a value of 9.2 seconds. Okay, so it asks me when. When will the object reach the ground? So I'm solving for that x or that t value. Okay. So we can only go with the positive answer. So it will take 9.2 seconds for that object to reach the ground. We cannot use negative 8.29 because it's negative. Okay, you're all done here. There's no reason to go back and plug this in to find length or width because it didn't ask us how high it will be when it reaches the ground. We already know that it's 0 feet. It asks us what time will that happen at. So we just need to figure out what that t value is or x value, and then you're all done. Okay, awesome. So here's our you try problem, and you can go ahead and try it out. I will give you the answers, but I want you to go through the work to see if you can get the same answers that I got. Okay, so your picture for this one should be a wall that you label 480 feet, and then to show an object being thrown off. Okay. When you solve for, this should be a t squared and a t here so that you can actually solve it. When you actually solve for t, you should get 1/2 seconds again. And then when you plug it into your equation for h, you should actually get 484 feet. Okay. Remember, please do the math so you can see if you can get to the same answers that I did. Okay. And for part C, when you plug in your formula, which again, this is a t squared and this is a t. When you plug, oh, and also h is equal to 0. So when you set this equation equal to 0 and then plug your a, b, and c into the quadratic formula, you should get that. How long did it take Jason to reach the ocean? It should take Jason 6 seconds. Okay, work it out and see if you get 6 seconds. All right, great job today. Please go to Haiku and complete the application of Quadratics IP. You may use this video, your notes, or office hours for help. Please email me with questions. Remember, my office hour is 10 to 11 every day. Okay. Some of you have private office hour. I know that Michelle has scheduled a private office hour with me on Tuesday. If anyone else needs a private office hour this week, just email me and we can set that up. Awesome job.